In lesson 4.1, the target states that I can find and compare unit rates. A rate is where we're going to start, and a rate is a type of ratio that compares two quantities measured in different units. So we're talking about putting together a fraction, and in the numerator and denominator we're comparing two numbers that came from two different units. So we're going to go over several examples in this video. To start, let's take an example of me driving my car. If I drove my car 240 miles, and when I went to the gas station to fill up, it took 10 gallons of gas to fill it up. Here I have a rate. It's a rate because it's comparing two different quantities, miles to gallons. Another example could be something like, I just measured my heart rate. I counted. My heart beat 120 times, 120 beats in 2 minutes. It's a rate because it's using two quantities of different units. Beats are being compared to minutes. Well, oftentimes we write a rate as a unit rate. 240 miles in 10 gallons. If I divide 240 by 10, I'm basically reducing the fraction. 10 goes into 240 24 times. So what I'd be left with is 24 miles per 1 gallon. So if I drove my car 240 miles and it took 10 gallons, an equivalent rate to that is 24 miles per 1 gallon, or 24 miles per gallon. If my heart beat 120 times in 2 minutes and I reduced 120 by dividing it by 2, I would get 60 beats in 1 minute. So my heart rate was 60 beats per minute, or 60 BPM. So we'll be looking at several different instances of rates. It often starts with a question. A lot of these questions are word problems. During exercise, Sonia's heart beat 675 times in 5 minutes. How many times did it beat per minute? So if I read the question, I see in the question, how many times did it beat per minute? Per is a fraction bar. So I know it's going to be beats per minute or beats over minutes. So it's helpful to read the word problem and look for in the question what kind of rate they're asking you to put together. So I'm going to put beats over minutes. Her heart beat 675 times in 5 minutes. How many times did it beat per minute? Well, it beat 675 times in 5 minutes. So if I divide 675 by 5, so I'm going to do the long division. 5 goes into 6 once. The remainder is 17. 5 goes into 17 3 times. The remainder is 2. Bring down the 5. 5 goes into 25 5 times. So her heart beat 135 times, 135 beats per 1 minute. And we write that with the abbreviation BPM, per being the fraction bar. But the answer would be 135 beats in 1 minute. Another example to try out, the Lawson family wants to travel 288 miles, and they're trying to cover that distance in 6 hours. The question is, what would their average speed need to be in miles per hour to drive 288 miles in 6 hours? So let's read the question. What should their average speed be in miles per hour? So it's miles over hours. So I'm going to build my rate as 288 miles in 6 hours. So if they can cover 288 miles per 6 hours in 6 hours, if I divide 6 into 288, I'll be finding how many miles they can cover in 1 hour. 6 does not go into 2. 6 goes into 28 4 times. 24 times 6 times 4 is 24. 28 minus 24 is 4. Bring down the 8, and 6 goes into 8. 6 goes into 48 8 times. 6 times 8 is 48. No remainder. So what I got was 48. And a lot of people have a hard time figuring out where to put that 48. What is 48? Well, it's 48 miles. And the denominator is 1. It's 48 over 1. 48 miles per 1 what? Well, hours was on the bottom, so it's 48 miles per hour. So their average speed to go 288 miles in 6 hours needs to be 48 miles per hour. We'll try one more example. A factory builds 960 cars in 5 days. What is the average number of cars produced per day? So if we read the question, it's how many cars are cars produced per day. So it's cars per day. So I'm going to take cars and I'm going to put it over days. I'm trying to build the ratio of how many cars are produced per day. If 960 cars are produced in 5 days, then how many cars are produced in 1 day? Well, I can accomplish this by dividing 960 by 5. 5 goes into 9 once, the remainder is 4, bring down the 6. 5 goes into 46 9 times. 9 times 5 is 45. The remainder is 1, bring down the 0. 5 goes into 10 twice. And there's no remainder. So the answer would be 192 cars per day. Okay, now you try. Click pause and solve these problems in your notebook. Show all of your work. Show how you built the initial rate and how you divided to find the unit rate or to answer the question. Then click play to check your work. Good luck. Alright, let's see how you did. Number 1. A Ferris wheel revolves 35 times in 105 minutes. How many minutes does it take to complete one revolution? So this question doesn't give you a whole lot of direction. You really need to read what the question is. So it's asking, how many minutes does it take to complete one revolution? So I'm reading this as minutes per revolution. It wants me to find the number of minutes per revolution. So I'm going to build my rate, and I'm going to put minutes on top. 105 minutes per 35 revolutions. And I'm going to convert this to a unit rate, because then I'll have how many minutes it took per one revolution. So I'm going to divide 105 by 35. Well, I can kind of see 35 times 3 is 90. 30 times 3 is 90, and 30 times 5 is 15. And 90 plus 15 is 105. So I'm going to go ahead and guess it's 3. If I divide 105 by 3, it would be 3 minutes per one revolution. So to answer the question, how many minutes does it take to complete one revolution? It takes 3 minutes to complete one revolution. But it's really important in your answer you put words to express what you mean. If you just put 3, it would be hard for us to tell if you meant 3 revolutions or 3 minutes. So it takes 3 minutes would be a good answer for number 1. Number 2, a 12-ounce soda costs 99 cents and a 16-ounce soda costs $1.19. Which size is a better deal? So we have to think about what we would want to do to put together a rate. Do we want to have ounces per dollar or dollars per ounce? So I have some choices in how I put together my rate. 12-ounce soda costs 99 cents. So I could find out how many dollars or pennies it costs per ounce. So it's 99 cents for 12 ounces. For a 12-ounce soda. For a 16-ounce soda, it's 119 cents for 16 ounces. So if I do the division to find the unit rate, or how much it costs per ounce, I have to do some dividing. I'm going to do 99 divided by 12, and I don't have a lot of room or workspace, so I'm just going to use a calculator. If I do 99 divided by 12 on my calculator, I got 8.25 for the 12-ounce soda. And again, that's 8.25 cents. Now it's per 1 ounce. It's a unit rate. The 16-ounce soda, using my calculator, 119 cents divided by 16 is 7.4 cents for 1 ounce. So which one's cheaper? Well, price per ounce, the 16-ounce soda costs less. It's a better deal. But I had to convert each to a unit rate to compare the unit rates to see which one's less. And that's the whole point of being able to compare a rate to a unit rate, so that you could make a comparison.